So in this video, we're going to focus on parabolas that are horizontal and are centered at 0, 0. And essentially what we're going to do is we're going to write equations for these horizontal parabolas centered at 0, 0 when given the focus and directrix. And then we're going to look at this in reverse, and we're going to find the focus and directrix when given the equation of a horizontal parabola centered at 0, 0. So what you're hopefully noticing as you look at this slide is that horizontal parabolas and vertical parabolas centered at 0, 0 are very similar. So hopefully what you're noticing first is that the focus and directrix are a distance away from this vertex called P. So this value of P, the distance between the vertex and the directrix and the vertex and the focus, is still important. The only difference here is to create the equation, we now have x equals 1 over 4p times y squared. So notice that the x and the y are just flipped for these horizontal parabolas. And then you'll notice that the p value is applied to the x coordinate of our focus, and our directrix has an x equals because it forms a vertical line. So we'll be using this knowledge to help us, but again, notice it's very, very similar to when we worked with vertical parabolas. So for each example below, we have a parabola that is centered at 0, 0, and our goal is to write the equation for that parabola when given the focus and the directrix. So what I'm going to do for each of these is I'm going to draw a sketch. So if I start off with this first one, I draw a sketch here of my coordinate plane, and I find that my focus is at 1, 2, 3, 4, 0, so it's right there. And I find that my directrix is a vertical line at x equals -4. So it's right here. So what I can see here is that I have a parabola centered at 0, 0, and it's opening to the right because it's going to open around that focus point. And then I can see that my p value here is 4. So we can see that the p value is equal to 4 because the focus and the directrix are both 4 units away. Now because this parabola is opening to the right towards the positive numbers, p is going to remain a positive 4. So now to write my equation, remember it's just x equals 1 over 4p times y squared. And in this case I can see that p is 4. So if I substitute 4 in here, I have 4 times 4. So my equation for this parabola becomes x equals 1 over 16 y squared. Now if I look at this next one here, this one is a little bit different. So we have a focus at -1/2. So I'm going to make these a little bit bigger and say -1/2 is right here. That's my focus point. And then my directrix is at x equals 1/2. So that's going to be about right here. So what I can see from this is I have a vertex at 0, 0, and I'm opening to the left because I want to open around that focus point. So my p value is 1/2, and it's a -1/2 because it's opening to the negative numbers, which is to the left. So now I use that same equation of x equals 1 over 4 times p, which is -1/2, times y squared. Well, this is really 4 over 1 times a -1/2. So that becomes 4 times 1, which is 4, 1 times 2, which is 2, and then it's a positive times a negative, so it's a negative, and that simplifies to -2. So if I rewrite this equation, I get x equals 1 over -2 times y squared is my equation for that horizontal parabola. So now we're going to apply this thinking in reverse, and we're going to identify the focus and directrix for a parabola with a vertex at 0, 0 with the given equation. So remember, the first thing we need to do is we need to identify our p value, which comes from this value right here. So remember, 5 was created by taking 1 over 4 times p. So we're going to say 5 is equal to 1 over 4 times p. And then in order to solve this, I like to turn this into a fraction of 5 over 1 and use cross multiplication that I learned in Algebra 1. So it'd be 1 times 1, which is 1, is equal to 4p times 5, which is 20p. So then I need to get p alone, so I divide both sides by the coefficient of p, which is 20. So I find that my p value is equal to 1 over 20. So now if I start to kind of visualize what this is going to look like, I can see that I have a vertex at 0, 0, and then because p is positive, I'm going to open to the right. So I know that my focus point is somewhere in here, and that my directrix is somewhere back here. Now, because my p-value is equal to 1/20th, and because my vertex is centered at 0, 0, I know that my focus point is in the positive direction. So I know that my focus is at the point x is 1/20th, or 0.05, whichever you prefer is fine, comma 0. So that's my focus point. I then know that my directrix is in the negative direction. So that's x is equal to negative 1/20th, or you can do negative 0.05, whatever you prefer. If you want to divide out that fraction, that's perfectly fine. Okay, so then from here, looking at the second example, again, I want to look and find my p-value. So I know that that negative 2/3 is equal to 1/4p. That's how it was created. So then I cross multiply here, so I get negative 2 times 4p, which is negative 8p. And that's equal to 1 times 3. So I then divide each side by negative 8. And I find that my p-value is equal to a negative 3/8. So what this tells me is, if I draw a little sketch here, because p is negative, my graph is going to open to the left. It's going to open backwards. And then I know that my focus point is going to be somewhere in here in the negative direction, and my directrix is here in the positive direction. So if I apply this, I know that the negative 3/8 is how far I move from the vertex to the focus, or the vertex to the directrix. So my focus point is going to be a negative 3/8, comma 0, or you can divide that to be negative 0.375 if you want to divide out that fraction. And then my directrix is going to be x is equal to, I'm in the positive direction here, so it's a positive 3/8, or again, you can divide that fraction out to get 0.375.